means they cannot destroy anything on it. With the new UFI you can do a lot of partitions. You have a double backup, you have the GUID partition table in the beginning of the hard disk and in the end of the hard disk, so if one is crashing you still have a backup. Instead, when the master boot record was crashing, if it was bad, all data has been gone in former times. The next big difference between legacy BIOS and UEFI are the purpose of the BIOS itself. When the old BIOS has just initialized the hardware, has done the power on self-test, it still has also provided some services afterwards, like interrupts and stuff like this, for changing the screen resolution, for adding something or for deleting something. The new UEFI BIOS is not expected to do anything. The new UEFI BIOS is just initializing the hardware and then passing control completely to the operating system. And if the operating system wants to communicate with the platform, it has to use ACPI. So the new UEFI BIOS is not providing some old legacy functions like interrupt 19, interrupt 13, interrupt 15. All this stuff is not provided anymore. The next difference is with the new UEFI BIOS, we have introduced the Human Interface Infrastructure, short HII. With HII, all the firmware and drivers are published to a kind of database. You have some kind of common browser for a consistent user interface. That means you have one interface for your BIOS and you're entering your BIOS, and also the option rooms, the drivers are inside of this interface. With the old legacy BIOS, you had your BIOS menu where you were changing your stuff. You had the menu of your option room where you could set up the PXE boot and all this stuff, or configure the LAN. You could configure the management engine and all this stuff. With the new UEFI concept, you could also integrate this dynamically into the BIOS menu, which makes it more easier for the end customer to use it. The next new thing with UEFI is the pre-boot environment. UEFI is providing some pre-boot environment which gives you access to all the hardware directly. So if you're starting the new UEFI, you have the possibility to access all the hardware. You have direct access to the bare metal registers. You can use the network stack for communication. You can directly access the memory with 64-bit addressing. You can run some applications or script on a shell. It's just perfect for diagnostic or stuff like this. How to do this and how to work in this pre-environment, we have the UEFI shell. And the UEFI shell is something like DOS, but it is not DOS. And it's something like Linux, but it is not Linux. It is not an operating system, it is just a shell which gives you the possibility to run some applications, especially programmed for it, and which can be a little bit organized or worked with like with Linux or DOS. For example, if you want to list the directories, you just can type directory, dir, or list ls for listing all the directory files. So it is looking a little bit like Linux, and you can use it like DOS or Linux. The UEFI shell itself is a shell and an application. The common file system is the FAT file system. So if you want to start some programs, you can take a USB stick, which is a FAT file system, and you can put your UEFI program on it, which has the ending .efi, and you can start it directly from your USB stick. Okay, let's talk again about the difference between legacy BIOS and UEFI. The first difference, as mentioned, is the language. When the legacy BIOS is programmed mainly in assembler, UEFI is programmed to 99% in C language, which makes it more human readable and more easy for debugging. The resources with legacy BIOS, you could use interrupt modes, or you used hard-coded memory access or hard-coded I/O access. With UEFI, you are using drivers and protocols instead, which makes it more dynamically and more secure if you want to change something afterwards. The next difference is the mode of the processor. When legacy BIOS started an x86 mode with 16-bit,